This is lecture 15, the last lecture of the geographical information processing. Today we will review the homework assignment. We will show the examples of the answers of the homework assignment. Firstly, we will explain the home assignment for lesson 6. The lesson 6 is about the homework assignment of lesson 6 is about the weather data calculation. Let's review the problems. The problem to analyze historical weather data. In problem 1, you read in a tricky data file and explore its contents. In problem 2, you will convert and aggregate the data from daily temperature in Fahrenheit to monthly average temperature in Celsius. In problem 3, you will analyze weather anomalies by comparing monthly average temperatures to a long-term average. Some of the terms in the sentences is not familiar with you, but they are common terms in English. So please refer to the dictionary if you do not understand the meaning of the terms. Okay, the problem 1. Reading in a tricky data file. Let's read the data file, data 109142.txt, which is the tricky part. The file includes the lines with this hyphen characters that don't belong to the data. So you skip the lines with characters. And values minus 999, which represents no data values. So you should NaN. This is you often encounter such kind of files with these lines and with these no data values. Before going to the data analysis, you should often manipulate the data in the files. Part 1. You should start by reading the data file and read the data file to variable called data. In reading the data file, you should skip the second row and plus 9999 into not a number n. Firstly, let's install the pandas and numpy. Then import a path as PD and import numpy as NP. Okay. Then we move to the your code here one part. By using the function read underscore CSV, we read the data file 1091402 with argument the delimiter underscore white is true and skip rows equals 1. This means that we will the argument na underscore value to convert not a number nan. We would like to convert the number minus 9999 not a number nan. So we specify the argument na underscore values as the list with one element minus 9999. Okay, let's run the cell. With the head method, let's see the first 5 lines of the data. File includes the 9 columns, which are stations, elevation, latitude, longitude, data, PRP, T, max, T, min. Here you can find a not a number. In the data file 1091402.txt, this is the minus 9999. We specify na underscore values as minus 9999. So this value is replaced with nan. Let's check the last rows of the data by the tail method. In part 2, you will calculate simple statistics based on the input data. Calculate how many not a number there are in the TAVG column and assign your answers to a variable called TAVG no data count. In order to do calculations of TAVG column, we specify with this style. This bracket, we specify the name of the column, TAVG. This means the column, TAVG columns of data. The function is to return the position of the true false values for each of the elements in the TAG column. If it is null, it returns true. If it is not null, it returns false. And we use the function sum for these returned values. So this represents the number of rows in TAVG with null values. Let's run this cell and print out the solution. We found that the number of no data values in column TAVG is 3308. We are doing the same task for TMIN column. Okay, now we see that number of no data values in column TMIN is 365. We have multiple rows for one total number of days covered data file. In order to unique function. By using this function, we can see the total number of days covered by this data file in date column. Now we know the number of days in the covered by the data file, which is find the date of the oldest observations. In order to find the date of the oldest observation, we will use the min function for the date column. There's some trouble in the kernel of the Python. So we have restart the kernels. So just a moment, please. Now I should relearn all of the programs from the first. Just a moment, please. Okay. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. The last observation is 2017 and 4th December. Now, for the average temperature for the whole data files, all observations from column AVG, and assign this answer into a variable called AVG underscore TEMP in order to find the average for the TAV column. And the print solution. The average temperature for the whole data set is 41.32. And we would like to find the average temperature, Tmax temperature for the summer of 1969. In order to find the data in this period of time, we use this command. We use the column date. We convert the data in the date column into the string type data. And we store the string data as the time underscore str column. Similarly, we convert the column time underscore str column, which are just created in normal line as a string data, and slice the first 6 characters in the time underscore str column. The first 6 characters represent the year and month. Then we use the first 6 characters in the time underscore str column for group by function. The group by function is to group the rows by the column year underscore month. The result is stored in the variable called grouped. We would like to know the data in the year 1969. So we define the list summer 1969 as with these as a list with these 4 elements. And this is the each key represents the year and month. The first 4 characters in this key represent the year. For example, 1969. So, month, for example, of 5. So, if the key is in this list, column as mean value key. for loop, we have temperatures in 1969 in summer variables. So, in order to obtain the average temperature in 1969, we will divide the sum of the summer values by the length of summer values. Now we know the average temperature of this is 67.82. Okay, now we move on to the problem 2. Problem 2 is calculating monthly average temperatures. In order to convert the temperature in Fahrenheit to Celsius, we define the function called FAHR2 Celsius. This is fairly easy. Method. The frame. Apply method is to apply the function specified as the argument to of the values in the TAVG column. In this line, we use the function FAHR to Celsius. So, this line means that we apply the FAHR to Celsius function to each of the number in the TAVG column. Okay? Then we store the returned values in the TAVG Celsius column of data frame. And we group the data by the year month column. Okay, so now we have the monthly data. The length of monthly data is 790. And the columns of the monthly data is temp Celsius. We would like to know the mean value of the temp Celsius. So, okay, which is 1. And the median is 4.73. Okay, this is the homework assignment for lesson 6. Okay. Next, we move to the homework assignment for lesson 7. Okay, lecture 7. Just a moment, please. Okay. Okay, the homework assignment for lesson 7 is to plot the data with random number generator. And the aim of this task is to create a simple scatter plot using random input values and random colors. As pseudo-random numbers, we use random.rand provided by the package called numpy. In order to generate 10 random numbers between 0 and 1, we run this function np.random.rand10. As a result of this program, we obtain an array with 10 randomly generated numbers between 0 and 1. Lastly, we will generate a x coordinate and y coordinate for 1000 points. In order to generate a 10,000 pseudo-random number or x coordinate for 1000 points, we use this function. And we keep these 1000 values, x coordinates. We keep the values as the x column. Similarly, we store the another set of y column. Yeah. Okay, let's see the generated values with the head function. The first 5 coordinates are like this. In the homework assignment, you often encounter the assert. Assert is to check whether the following statement is true or false. In this line, we are checking that the length of the data is equal to 1000 or not. If the length of the data is different from 1000, it prints out this sentence. There should be 1000. Okay, we generate a 10,000 random looking plot. To generate 10,000 random numbers, we use this program again. Okay, now we have a random numbers. Here we import a matplotlib.pyplot package, which is popular for plotting in Python. In order to use this, in order to show figures in this browser page, we need this line. In case that you run the Python program in terminal or command prompt in Windows, you don't need to write this line. Now I am using the Jupyter Notebook environment in web browser, so we write this line. Then we use the scat function to plot the x coordinate, y coordinate. In the title and x label. And this save figure function is to save the generated figure into a file, image file. Generating and saving the image, but many of the students failed to save the figure in the image file. It is very important to check that your program works as you intended. Some do not succeed in saving the image file. Okay? Done. Let's move to the second file of the lesson 7 assignment. Okay, just a moment, please. I'm opening the file for the second part of the assignment. The second part of the assignment for lesson 7 is to plot the temperatures. The input data file is data Helsinki Vantaa.csv. File includes the columns date, USAF, station number, and temp F and temp C, and diff temp C and diff C. Firstly, we read the data files. This is a CSV file, comma cited value file. And in order to read the CSV file by using the function in pandas, we use the read CSV function. Okay. And most of the students succeeded in reading the data file. There you can find the data like this. And let's check the number of rows in the data frame. 706. And we would like to consider the data for a 30-year period. So let's select the data from January 1988 to December 2018. And the selection in a new variable called selection. Firstly, we convert the data in data column into a date time format. Just a string. So the computer does not recognize it as a date. So we should convert the time. In order to convert the string into a date time provided by the pandas package. And in date time, okay, and we would like to know the data from 1988 to the 2018. So we define the from the variable 8811 and the 2D as the date time 2018 12 1. And this function date time is a function to aid data in date time format. This represents the date 2018 1st December. In order to select data during this period, we in this bracket the first part specifies that the date time should be later than from D. And second condition means that the date time should be earlier or equal to or earlier than the 2D. Okay, so by this statement, we can select data for a 30-year period from January 1988 to 2018. Let's run this program. And let's check the result. Now the data selection starts from this row, 1988. Okay. Then we check how many rows of data we selected. The number of data we selected is 307. And part 3. In part 3, we create a line plot that displays the temperatures, temp underscore C, for year months each month in the 30-year time period. And we specify the size of the figure as 14.6 in this line. And plot the temp C column of the selected data frame with lines. The style of the line is k dot hyphen. The meaning of these arguments is described in the reference of pandas. So let's see. Let's refer to the reference manual of the pandas if you would like to know the meaning of these argument values. And these lines are for specify the title and X label and Y label. And this is to save the figure as an image file. Again, some students failed to save result as an image file. Then some succeeded in save the figure as the image file in the first part, the random plotting of x coordinates, y coordinates. But the same student sometimes fails to save this plot as an image file in the part 2. So again, be careful to check that your program intended. Okay, let's move to the exercise, the homework assignment for lesson 8. Again, just a moment to open the file for lesson 8. Okay, the homework assignment for lecture 8 is to create basic geometries. In order to create the basic geometries, you are required to define a function, create point, GOM, and so on. Firstly, let's define the function. Create a point geometry called create underscore point underscore GEOM. In order to use the geometry object, we should import a point line string polygon from the shapely.geometry. The function to create a point geometry object is fairly easy. The arguments are x coordinate and y coordinate. And by using these two arguments, just call and return the point x coord and y coord. And let's check that the function works correctly. By printing the return values of the function create and point underscore GOM, you see this one. So we know that the function works as we intended. Okay? And by calling the GEOM underscore type, we check the type of the geometry object of this point one variable. Some students fail to run this command. Okay. To create a function called create underscore line underscore geo that takes a list of shapely point objects of those input. The argument should be a list of shapely point objects. And this point should be a of point object. Okay, so firstly, we is surely the list. We use assert. In this line, we check the type of the argument. If the type of the argument point is different from the list, the function stops with assertion error. Okay. Some as this. But it doesn't work because this is a string. In the type of the point is list, you should use this statement. And we would like to define a line. So the number of elements in point should be equal to larger than 2. So we make the length of the argument point with a sort. Okay. Now we know that the argument point, the type of the argument point is list, and the number of elements in point is equal to or larger than 2, and we can give this point to a line string. The argument to the create line GEOM should be a list of point. So we give the list of point objects like this. Okay, we have 2 point object elements here. Let's run the program and check the result of this function. Now we see that the line 1 is the line string, which consists of 2 points. The first one is this point and the second one is this point. Okay, it really works as we intended, and geometry type of the line 1 should be a line string. Okay, line string. And the third part is to create a function, create polyGOM, that has one parameter called COORDS. So in the of the function, we check the type of the argument COORDS. And to define a polygon, we need at least 3 points. So we check the length of the argument COORDS, the second line of third line of the function. Okay, and each element of the COORDS should be a tuple. So in this for loop, we check that each element of the COORDS is a tuple. Then we create a polygon with this argument COORDS. Okay, let's define the function. For testing the function, use 3 coordinates to define the polygon. By specifying this list, we should obtain a triangle. A polygon consisting of consisting of points. it starts from this point and goes to this point and goes to this point and returns to the first point. This is the same with this one, okay? So you see 4 pair here. You see 4 pair here, but the first one is and the last one is the same. So the polygon consists of only 3 points. Okay. Okay, done. Then the problem 2 is to operate the attributes of the geometry. The first problem is to define the function called get_centroid that has one parameter called GOM. The function is to obtain the centroid of the geometry object specified as an argument GOM. Okay? When you define the function, it is very important to include the assertion to check that the argument, given argument, is correct or not. In this function, we check that the types of the argument GOM is surely a point or a string or a polygon. If the type of the GOM is different from the one in this list, this statement does not work. Okay? So it is generally it is important to include the assertion when defining the function. Okay, this cell is a little strange. We run the four statements, but all of the result is stored in the same variable poly1. So this is mean the first 3 lines means first 3 lines are necessary. Then we run the last line of this cell to create a polygon with 3 points. And we are getting the centroid of this polygon, poly1. Okay, the center is a point with the coordinate. These coordinates. Okay, and here is fairly easy. The geometric object already has a field called area. So just refer to this attribute area to obtain the area of the geometric object. The advantage of defining the function area is that we can include the assertion line. Okay? the given argument polygon is different from the polygon, then the polygon dot area should not work. Let's run this. The area of this polygon is 17.2754. And the third part is to define the getLength function. Again, in order to obtain the length of the geometry, it's very easy. Just refer to the attribute called length. But again, the advantage of defining a function to get length is that we can include the line for assertion, like this. Then let's run the program. Okay, the length of the polygon is 121.328415. Okay. And docstrings. Okay. Docstrings is example of the doc line here. Doc line starts from this sequence of string. By defining this docstring, you can use the help function for this function. Okay, for example, if we run the help get area, the argument to get area, we will see this part. Okay, get area of the polygon here. Okay, very important to describe the usage of the function. If you just write a comment like this, what happened? Let's see what happened if we include a comment line like this and run the help function. Okay, you don't see this line, comment 1, by running the help function for getArea function. Okay, here. If you use this style, you will see this statement as a result of the help function. Okay? The docstring is to show the usage of the functions when function is executed. Some students just write the usage by comment lines like this one. But the descriptions with this comment symbol is not displayed as a result of the help running the help function for this function. So be careful not to use this style as a docstring. Okay? Some students write the docstring fairly almost perfect strings to describe the usage of the functions. Okay, done. Okay, let's move to the second part of the homework assignment of lecture 8. Okay, the second part of the homework assignment for lecture 8 is to deal with the files containing the movement of the users. Okay, one of the most typical in GIS is the situation where you have a set of coordinates in some file. You need to map those. Python is a really handy tool for this kind of situation as it is possible to read data from any kind of input data file. And how we can read data from a file and create point objects from them. Okay. Here is a data set containing the travel time between specific locations in Helsinki regions. Travel times 2015 Helsinki.txt. It includes these kind of columns. In this exercise, we are interested in the column from x from y to x to y total route. Firstly, we read the data in the file by using the CSV function. Okay, and the result of reading the file is like this. Okay, we see the columns from ID to ID, from ID to ID, root number at from X from Y to X. Okay, and 40,643 rows. And we are interested in these 4 columns. So we extract the data of these 4 columns, and again we store the data with these 4 columns as data. Now the columns of data consist and we need to create a point object from this data. So firstly we create an empty list origin point and point. And in order to define the point from this, from x from y and to x to y column, just use this function. And the generated point is inserted into the list origin points and this point by data frame. As an example, let's check the first point in origin point and this point. Okay, the x coordinate or coordinates of the origin point is this. And the x coordinates, the y coordinate destination are these. So these 2 points, origin point 0 and this point 0, represent the movement from this point to this point. Okay. And so we create the line strings to represent movements from this origin point and this point. The line is to a set of strings to represent the movements of the people from origin points to the point. Okay, now we have created all the lines from origin points and points. We calculate the total distance of these origin points and test points. Okay, we are done. Course, we have learned basic concepts and basic skills to manipulate data and objects in geographical information processing. And skills in geographical information processing is very variable. It is difficult to find people who have such kind of skills. So if you have learned the contents of this course sufficiently, you have strong skills. You are a very good human resource for the companies in industry. In this course, we learn skills to manipulate the data and geometric objects in Python, mainly in Python, but there are a few products to manipulate geographical information by graphical user interface, including ArcGIS. Okay? ArcGIS is a famous product for geographical information system. From this June, by this June, the students in Aoyama Gakuin University can use this ArcGIS with the license provided by the Department of Economy. But the license changed in this July, so you cannot use this product. I like to use this, but there exists a freely available software called QGIS. If you are interested in what can be done with this kind of GIS software, please refer to the web contents of this kind of software on GIS. Okay, now this is the end of this lecture 15 and the end of this course, Geographical Information Process. There are no exam for this course. We will grade based on submission of the homework assignment up to the last lecture. Okay? See you. This is the end of this course.